Now we're going to look at finding equations of lines. Well, how do we find equations of lines? Well, there's two formulas that we need to have committed to memory. The first one is slope-intercept form. Well, slope-intercept form is represented by the formula y equals mx plus b, and that's where the m is the slope and the b is the y-intercept. So in slope-intercept form, m is your slope, b is your y-intercept. Another formula we have to have committed to memory is point-slope form, and that is represented by the formula y minus y1 is equal to m times x minus x1. And this is where m, again, is still your slope, and x1, y1 is going to be a point on the line. In order to obtain the equation of any line, we need to know slope and a point on that line. Once we have that information, we can plug it into our point-slope form and then solve for y to get into slope-intercept form. So we have to look at the given information and we have to plug it into one of these formulas to find the equation of the line. So let's take a look at example 7. It says to find the equation of the line and write our answers in slope-intercept form when possible. That is solving the equation for y. Alright, well, let's look at the first one. I have that my slope is 3/5 and that I'm through the point 1, -2. So I'm given m, and I'm giving a point which is an x1, y1. Well, all I have to do is plug this information into my point-slope form. Remember, point-slope form is y minus y1 equals m times x minus x1, and we need to have that committed to memory. So let's plug in where we can. So y minus, instead of y1, I can write a -2, and that's going to equal, instead of m, I can write 3/5 times x minus, and instead of x1, I can write 1. So I've plugged in all the given information into the formula, and now I'm going to solve this for y. So cleaning this up, I get y plus 2. If I distribute, I'd get 3/5 x minus 3/5. And if I don't like fractions, I can clear the fraction now. I can multiply everything by 5. So I'm going to multiply both sides of my equation by 5 to get rid of that denominator of 5. So I end up with, and I'm going to move it up here, 5y plus 10 is equal to, well, when I multiply 3/5 x times 5, my 5's cancel and I'm just left with 3x. And then if I multiply 3/5 by 5, again, I get just 3 on top. So I end up with 5y plus 10 is equal to 3x minus 3. Now I don't have a fraction. The problem is less intimidating, so just solve for y. If I move 10 over here to the right, I get 5y is equal to 3x minus 13. Divide both sides by 5 in order to solve for y, and I get that the slope-intercept form of this line is 3/5 x minus 13 over 5. Let's look at example 8. Same thing we need to do is find the equation of the line. Now the slope for this particular problem is m equals 0. Okay, well, m equals 0, remember, we have committed to memory that that's going to give us a horizontal line. Well, we haven't really talked about this yet, but all horizontal lines are in the form y equals some number. And the number that they equal is always going to be whatever y is equal to in your ordered pair. So we're going to actually work this problem out using point-slope form, and then I'll show you that you can just skip to this shortcut and you'd get the same answer. So let's do this with point-slope form. So y minus y1 would be a -2 equals m is 0 times x minus x1 is 1. Working this problem out, I have y plus 2 is equal to, well, 0 times anything is 0. Solving for y, I get y is equal to -2. So the equation of the line that passes through this point and has a slope of 0 is y equal -2. Let's look again at what I said shortcut-wise. I said when you have a slope equal to 0, you're a horizontal line. All horizontal lines are in the format y equal a number. Well, what exactly does y equal? Well, in this case, it's the y value, and my y value is -2. So using this shortcut, I could have skipped to just writing y equal -2. Example 9 tells me I have a slope that's undefined and that I'm through the point 1, -2. Well, again, what I need to do is determine what kind of line gives me an undefined slope. We talked about this earlier. Those are vertical lines. Well, if horizontal lines are in the form y equals a number, vertical lines are going to be in the form x equals some number. Well, if we think about what number this equals, it's always going to be whatever x value we have in our point. This we cannot plug into point slope form because I can't distribute undefined anywhere. This particular type of problem must be committed to memory. If you have a slope that's undefined, your equation of the line is always going to be x equal a number. So you're going to write, okay, undefined slope, x equal, you're going to go to your point, figure out the value of the x coordinate for that point, and then say that that is your line. So for this particular problem, given an undefined slope and going through the point 1, -2, the equation of our line would be x equal 1. Let's look at the last two examples for finding equations of line. Example 10 is -3, 4 and 9, 1. So I don't have slope this time. All I'm given is 2 points. Remember, we need two things to find the equation of a line, slope and a point on that line. Well, I don't have slope, but I'm given 2 points, so I can go back and use that slope formula that I already have committed to memory to find my slope, and then I can find the equation of a line. M is equal to, again, I'm just going to label x1, y1, x2, y2. So m is going to equal 1 minus 4 divided by 9 minus a -3. Well, 1 minus 4 is -3, 9 minus a -3 is positive 12, and this reduces to -1/4. So my slope is -1/4. Great. Now what I need to do is find the equation of a line and put it into point slope form, which again is y minus y1 equals m times x minus x1. Well, let's plug in what we know. Y minus, instead of y1, I can write 4 equals m. Instead of m, I can write what the slope is, which is -1/4, times x minus, and instead of x1, I can write a -3. Let's clean this problem up. Y minus 4 is equal to, this would be -1/4, and x minus a negative is really x plus 3. Let's distribute that -1/4 on the right. I get y minus 4 is equal to -1/4 x minus 3/4. Well, let's say I don't like fractions, so I want to clear the fraction. So I need to get rid of the denominator of 4, so I can go ahead and multiply both sides by 4 to get rid of that denominator. So I have, moving up here, 4y minus 16 is equal to, well, -1/4 x times 4, my 4's cancel, and I'm just left with -1x, and then minus 3. So I have 4y minus 16 is equal to -1x minus 3. Well, now I don't have fractions, so the problem is less intimidating. Move 16 over here to the right-hand side, and I get that 4y is equal to -1x plus 13. Divide everything by 4 to isolate y, and I get that y is equal to -1/4 x plus 13/4. So the equation of the line that goes through the points -3, 4 and 9, 1 is -1/4 x plus 13/4. Last example, I have f of 6 is equal to 3 and f of -2 is equal to 4. Well, how would I figure out that? I'm not given ordered pairs. Well, actually I am. Recall that this is the x input and this is the output, which is the y. So you are actually given an x and a y, just in a different format. So we can treat this problem just like we did example 10. So let's call the first one x1, y1, and the second one x2, y2. Plugging into my slope, I get that m is equal to 4 minus 3 divided by -2 minus 6. If I work this problem out, 4 minus 3 is 1, -2 minus 6 is -8, so the slope of the line that passes through those 2 points is -1/8. Plug it into your point slope form, and we get y minus y1 is 3 equals m -1/8 times x minus 6. Distribute your -1/8, y minus 3 is equal to -1/8 x plus, because -1/8 times a negative 6 would be a positive 6/8. And I'm not going to reduce that right now because we're about to clear the fraction, so I'm not going to worry about that. I want to clear the fraction. 8's my denominator, so let's multiply everything by 8. So I have 8y minus 24 is equal to, denominator in that cancel, so negative 1x plus 6. I no longer have a fraction, so the problem becomes easier. So let's move 24 over to the right. So I would get 8y is equal to negative 1x plus 30. Divide everything by 8 to solve for a y, and I get that y is equal to negative 1/8 x. I can reduce 30 over 8, so let's go ahead and do that. They're both divisible by 2, so you get 15/4. So the equation of the line that passes through the points f of 6 equals 3 and f of negative 2 equals 4, which is the point 6, 3 and the point negative 2, 4, is negative 1/8 x plus 15/4.